So we've looked at log and exponential properties. We've looked at just log properties. Now we want to look at just exponential properties. Okay, they're very similar to that condensing and expanding, but they're not exactly the same. Okay, but if you think about that, it kind of makes a little bit of sense. So our first exponential property is that when I multiply the same base together, I will add their exponents. So that's similar to that product property where we had multiplication became addition. So it's very similar, it's just going to look different. So what that might look like, I'm just going to write my examples up here. That might look something like if I had 5 to the x times 5 to the y, then I would get 5 to the x plus y. Another example might be, let's say we have 2 to the 7th times 2 to the 3rd, which would give me 2 to the 10th. Okay? Now, the next property is that when I have the same bases being divided, that turns into subtraction. Again, that's similar to our quotient property for logs, because remember when we had that log property of our quotient property, we were taking division, turning it into subtraction, and vice versa. Same idea here. So let's say that we have x to the 3rd divided by x to the 4th. I would subtract those, so I would get x to the -1, and we'll deal with negatives here in a minute. Let's say I could have the same thing with numbers. So let's say I have 9 to the 5th power divided by 9 to the 3rd power, I get 9 squared. So it's the same idea. I'm going to take those values and I'm going to subtract their exponents. Now, the reason that we have this next property is because of something like this first problem we saw here. When I subtract, sometimes I get negative numbers. So in exponentials, that's an issue. So a negative number must go to the other side of the fraction bar. So, for example, if I have a negative here, it's going to go 1 over that value, because remember there's like a 1 underneath here. So let's see what that might look like. Let's say we have 5 to the -3. That would really be 1 over 5 cubed. Another thing we could have is, let's say we have 1 over x to the -8th. That would just be x to the 8th. You could put divided by 1, but you don't need to put that because, remember, we don't really need anything with division of 1. Our next property for these exponentials is dealing with what happens if you have a fraction. So we looked at when we're multiplying same bases, when we're dividing same bases. Now we're looking at there's only one base. Maybe it was negative, which we just saw that, and then maybe it's a fraction. So a fraction is actually going to become a radical. We looked at radicals earlier. Now, I could have any fraction, okay, and then we're going to look at specifically fractions where we have a numerator of 1. All right, so let's say, for example, we had something like x to the 3/5. So x to the 3/5, what I'm going to do is I'm going to make a radical symbol. The numerator goes underneath, and the denominator goes on the outside. So we'd call that the 5th root of x cubed. All right, we could do another one. Let's say we had 4 to the 7/3. That would be written as a 3 on the outside and a 4 to the 7th on the inside, right? Now, one thing that we know is that just like the common base of logs was 10, the common base of natural logs was e. If I have x to a 1/2, I don't need to write a 2 out there. That's known as the square root, so it's already like we don't have to write it. Anything else, though, I will have it on the outside of this radical, okay? So if there's no number on the outside, we know that it's like a 2 there. That's that common radical. So now we should be able to simplify using exponents. So let's see if we can do one that's a little bit more complicated. So it involves more than one of these properties. So let's say that we have x cubed y to the fourth x squared over y to the seventh. All right. So doing this, I can see a couple different properties. The first property, and it doesn't matter which order that you go in. The first property that I'm going to do is I see that I've got the same base, x, being multiplied by an x here, which means that I'm going to add those exponents. So I'm going to get x to the fifth. Then what I notice is that I've got division here, which is going to turn into subtraction of my y's. See, I'm matching up the common bases. So now I'm going to say 4 minus 7, so I'm going to get -3. But I would like to say that's my final answer, but I notice I've got a negative here. So what I really need to do is move that into the denominator to make it positive. So I get x to the fifth divided by y cubed. All right. Let's try one more and make sure that we've got it here. So let's say we've got x to the fifth, y cubed, x seventh, y ninth, divided by x squared, y to the fourth. All right, so let's see what we need to do here. So I'm going to start matching up the variables. So I've got an x and an x on the top, and then I've got an x in the denominator. So let's deal with the top ones first. I'm going to add those. So I'm going to do 7 plus 5, which is going to give me a 12. Then I'm going to do that value minus that 2 because I've got an x squared in the denominator. So now I'm going to take that 12 and I'm going to minus 2. So I'm going to get an x to the 10th. So I added the 7 and the 5, and then I subtracted the 2 to give me a total of x to the 10th. All right, so now let's match up my y's. I'm going to have my y cubed, my y ninth, and my y to the fourth. So my 3 is going to get added to the 9. So I'm going to have 9 plus 3. I'm going to get 12. Then I'm going to have this 4, which is in the denominator, so I'm going to need to subtract 4, which is going to give me 8. So then I'm going to have y to the 8th. Since all of that's positive, that would be my final answer. All right, so now I should be able to look at individual exponential properties as well as looking at a combination of different properties and simplifying them all the way down.